let us start with this problem. The problem in hand. एक बार देख लेते हैं what exactly is the problem talking about. Gravity in this problem is in the cross direction. The problem is like this, that on a table there is a light string of length d which is connected with a rigid rod of length L, capital L. The angle of this string with a line on the table, that angle is given as theta. And there is this uniform rod is having a mass of m. And again, there is a ball which is having the same mass, moving with a velocity v0. It hits the rod at the end and sticks to it. The question that he wants you to answer is that what is the tension in the string immediately after the impact? And what is the data given? Capital D is known, capital L known, theta, cos inverse of 1 by 3, that is given, and this velocity v0 is also given. Rest, bullet ka mass m and the rod also of the same mass. This much information is given. The question categorically says that the bullet hits the rod at its right end with a velocity v0 and gets lodged in it, the impact being nearly instantaneous. What is the tension in the string immediately after the impact? And assume that the string does not break. That assumption is given. Now, the problem comprises of lot of informations which we have to carefully consider if we want to solve it correctly. As, let's say, at the instance when the impact between the ball and the rod happens, just after that impact, the center of mass of the system is somewhere here at a distance of L by 4, and this distance is 3L by 4 from the end, right? Other than attaining an angular velocity omega about the new center of mass, the combined center of mass also seem to have some velocity which I am deliberately breaking into two directions, where one direction that I want to take, actually the problem does involve constraint relation also. So we have to be careful in the choice of our axis. So what I am thinking is, if I presume this direction, which is perpendicular to the length here, and I take one velocity which is perpendicular, call it v1, some velocity v1. And I talk about some velocity which is in this direction. I'm not interested in writing this right now. We'll eliminate that term, don't worry. Right? And we understand that with the vertical, the angle is theta. So, I mean, here also, this angle that it is making with the horizontal is theta. Theta. So, this angle here is theta. Because these terms are not relevant for me. This V1, V2, whatever. I'm not interested in writing these terms. I'll finally eliminate all these things. What is more relevant for me is just after the impact, I do generate a omega, and the end point of the rod here does acquire a velocity which will be perpendicular to this string, and let us call that velocity to be some u. Because by constraint, this end cannot have any velocity along the length. So उसके पास जो velocity होगी, that can be only perpendicular to the string. Net velocity. Just after the impact. So I understand that I'll have a velocity here, which is u. This much is fine. And the angle of this line is some theta. One more thing. During the collision, I'm interested in conservation of linear momentum, but that I can do only along the purple line. Because of this impulsive tension here, I can conserve my momentum along this direction. So this is my line of action for conservation of linear momentum. So let me write my first simple equation. I would have written m into this guy having v naught here. So with respect to this line, the line which is parallel to this, I'll have this angle here is 90 minus theta. So I have got m v naught sine theta term in my momentum, in the linear momentum just before the impact. Right? And just after, because center of mass velocity, so I have taken this velocity as some final velocity perpendicular to the string. So I could have written this term as 2m vf perpendicular. Check this. m v naught into sine theta should be equal to 2m vf perpendicular. So this equation gives me this vf perpendicular term, and this vf perpendicular comes out as v naught sine theta divided by 2. ये तो ठीक है. This term is v naught sine theta divided by 2. Right. Okay. Now I want to write one relation between omega vf perpendicular and u. And check, if I look into this point, this endpoint here, what are the terms I am expecting here? I'll have a vf perpendicular here. I'll have the second term, this guy, second term, and I'll have the third term here, which is omega into 3L by 4. Right? So very clearly, the second term which we are expecting here and the angles. So this was 90 minus theta. So I'm trying to write my second equation. Let's call this as some v prime. Call this term as some v prime. Already you have said that he has got a, so u that I'm writing here is actually 3L omega by 4 sine theta minus Vf perpendicular. That is my u. Vf perpendicular is known, and I have one more relation there. This term I haven't used, not required yet, but whenever required, I could have written that this will balance, right? So V prime should be equal to 3L omega by 4 cos theta, the outward component of this term. Yeah, because ये दोनों terms मिलके तो u बन रहे हैं. So the second component should balance that term, because this point cannot have any velocity along the length of the string. Still, we are stuck with these values. I need one more, and that will come from conservation of angular momentum. Still, what are the variables we have had? I have had Vf perpendicular, V prime, omega, and u. These were the 4 parameters. 3 equations I have written. One I will write by conservation of angular momentum. And I like to conserve the angular momentum about this point. So that initial term is coming out as m v naught L. Now we have to be careful as we write the final term. क्या लिखना चाहिए? M R cross VCM plus ICM omega. Right? So ICM omega term. You getting the point, no? So I about this point, अलग से लिख लेता हूँ, that I that is needed there, that should come out as ml square by 12 plus m into L by 4, the whole square. That is for the rod, and plus that point, which is ml by 4, the whole square. So basically, ml square, कितना बन रहा है? 1 by 8, 1 by 12. 5 by 24. ठीक है ना? 5 by 24 ml square. Is that fine? ठीक है? So then this becomes ICM. So that is 5 ml square by 24 I term into omega. Omega was anti-clock. Yeah. This term plus in the RHS. RHS, I need to write one more term. What is that? That we have to be very careful about, because that will be 2m mass, lever arm 3L by 4, and the total components of both the people, which is normal. So basically, iska sign. So V naught sine square theta divided by 2 plus the second term V prime. What is that? V prime sine 90 by V prime ka cos. I think that is V prime cos theta term. V prime cos. Is that fine? M R cross VCM I wanted to write about that point. So total momentum, angular momentum of that point, and angular momentum about center of mass. So these are the terms I have written. Solve these equations. Few results I will use. You can check the results accordingly, which I am writing in this problem. These values will be required for solving the further parts in the problem. Check what are the terms you are getting. So mainly, the omega that I am getting is V naught by L. The U that I am getting is V naught by 3 root 2. These two things first. Rest, in fact, are not even required. You can check, eliminate everything. What I am interested in is a U term, which I am writing here, and omega. In fact, all that VF perpendicular, V prime, you try to eliminate. VF perpendicular was not even there. V prime to likh liya tha. If you substitute here, basically I needed omega and I needed U. All good? Up to this stage? Now the problem enters into the real domain. The problem iske baad ab start hota hai, kyunki देखो, one thing in such problem which is important is, if you randomly take variable, I will write 5, 6, 7 equations and I will take 15 minutes to solve this. But the point is that because you have to use this constraint that this velocity is normal, so try to use fewer variables. Directly wo use kar lo agar aap, so definitely problem will become a bit easier. Because after this, still, what happens is, once we are known with this data, now what happens? Now, just after the impact, what will happen? He will provide you some tension. Now, let us look into the problem. Impulse वगैरह सब हो गया, velocities I have attained. Now, let's look into the forces. So, I will have a tension here. The total center of mass is somewhere here, concentrated here, L by 4, 3L by 4. I have a total mass, which is 2m. Right? Okay. So as far as the center of mass is concerned, now this angle here is theta. Center of mass will have an acceleration in this direction only, and that is t by twice of m. And this line will also be at the same angle theta. This is the acceleration of center of mass, AC, because the only force is t just after the impact. Other than this, if because about the center of mass, if you observe, you have got a omega, right? And you will have an alpha because about center of mass, this tension will provide alpha. So alpha will be in this direction. Omega was because of the jerk. That was anti-clock. But the acceleration will be, angular acceleration will be provided by T, the only force about center of mass. So about center of mass, I will have an alpha. Now what I'm trying to think is, I want to write the accelerations of this point here, this point. So by the concept, whatever center of mass acceleration and that will come. So this guy will have a, forget about the force now. This guy will have an acceleration here, which is T by 2m. That is because of center of mass. And about the center of mass, he will have two more accelerations. One is rightward, which is omega square 3L by 4. Observe carefully. Omega square into 3L by 4 is a centripetal acceleration of this point about center of mass. And there will be one more, which is upward, which is actually 3L by 4 multiplied by alpha. Right? These two and this. So these are the three accelerations he will have. But because he is constrained to move by virtue of this string, his acceleration along the centripetal direction. So now I'm writing the main equation. So T by 2m is fine with me. This angle is theta, this is 90. So ye ho gaya theta, and this is 90 minus theta. So what I should write is T by 2m minus omega square 3L by 4 cos 90 minus theta. So that is sin theta term minus, and plus 3L alpha by 4 and cos of this guy, cos theta term for this guy, this term. That should be equal to, if the length is d, u square by d. Now you understand the utility of u, which in the beginning I have taken on the previous step, because I knew, because this guy can pursue a circular motion, iska centripetal acceleration will be this. This is actually the main equation for the problem, rather the fifth equation in hand. And ideally, this equation should help me find out the value of tension. All the parameters like omega, u, everything I've got. The alpha is the only unknown. So let me write the sixth equation. And for alpha, directly I will write torque equation about center of mass. Who will provide the torque? T. So T cos theta into lever arm 3L by 4 upon moment of inertia I, that should be equal to alpha. I think you calculated this. I, which was 5 ml square by 24. This was I about the center of mass. So you use alpha in terms of T here. Now omega and u are already known from the previous page. Substitute everything, you'll get your answer for T. You can verify afterwards. I'll just write the final expression. So the answer for T comes out as 5 mv naught square upon 4 whole multiplied by 1 by 18 capital D plus 1 by L capital L root 2. This is the answer to the question. 5 mv naught square upon 4 whole multiplied by 1 by 18 capital D and a factor of 1 by L root 2. So I think conceptually the problem is clear too. Okay, let us move on to the second question for the day. Now, in this problem, analyze this problem for a sound signal which is moving on a circular path. So, I'll show you other parts of the problem too, but try to focus on this data first. A lot of things you have to do geometrically to finally converge at the final solution. I'll give you the graph also appropriately because this graph was drawn on scale and these values and grid does have importance, right? Don't worry. Let us read the question first. A sound source S is performing a uniform circular motion with a time period of t. Now it is continuously emitting sound of fixed frequency f0. The person who is moving in a uniform circular motion. There are two detectors placed somewhere in the plane of that circle. And both the detectors does receive frequencies, and he has plotted the frequency received versus time instance graph. जो वो frequency receive करते हैं, this value is 1300, this value here is 800. There are other values also which are not depicted, but इसका maximum minima दिया हुआ है. So the two detectors placed somewhere in the same plane as the circular trajectory of the source, and the frequency of the sound received by the two detectors is plotted as a function of time. The clocks of the two detectors are synchronized. Or the clock एक ही है, time watch एक ही है, the common watch है. Now, through the graph, there are few things he wants us to calculate. And you have to be patient. The best problem comes in the last step. So he's building up the problem. I'll come to that. Actually, the problem, no, last में जो पूछेगा, which is important for us, is the distance between the two detectors. So while you are solving this, you keep your focus on the last part, that you have to find out the distance between the two detectors. Nothing is said about them. Just looking into the data, you have to find out everything, which is a very complicated problem. Not obvious at all. Very, very complicated. So, chalo, dhire dhire, let us try to, bridge that complication, and he is helpful. Whatever data you are able to perceive, let me just show you that data again, give you some time to think on the data. So, let me just draw this graph for you. Try to interpret as much information as possible from this graph. I'll help you out in some informations. The value that we are observing here, so this is 16. I mean, this point here is matching with the grid. This is 16. You understand these points are like this is 15, intermediate point. And this value here is 25. So this peak point to the min point, this is 16, that's what I said. Or ye 25 point. So this happens. As far as the lower one is concerned, so one thing is clear, that if you look into the time gap between maximum frequency to minimum frequency, that comes out to be 9 seconds. So this gap, this will be all useful for us. So just focus on this. 9 seconds mein max to min aa raha hai. Even if you observe the other graph here, this value here is 20. And I mean, this is 20. And he is also observing this value, which is 29. So if I look into the other graph also, there's a gap of 9 from max to min. Wo gap same, 9 seconds. Now, if you look into his peak again, the first one, so नीचे से जाके फिर दोबारा when he attains the peak, this value is 40. So basically, you have gone from 16 to 40. So basically, 24 seconds, peak to peak, and peak to min 9. Okay? And even if you look into the second graph, this is the only critical thing required, then you can start solving. So 20 is this, and when you look into the peak again, this is somewhere here, this peak, this value, and that comes out as 44. That comes out as 44. So even in this case, from max to the next max, it is 24-second gap. So for both the people, now first speculation seems simple for me. जब वो पहला सवाल पूछता है, what do you think is the time period of the source? The first answer seems to be 24 seconds. 24 seconds. If I am moving on a circular path, है ना? So the instance when my friend receives maximum for any detector, whether he is inside or outside, for both of them, for outside person or inside person, for outside it is very simple. Your tangent which is directed towards him, and then again there will be a tangent. So if there is someone who's sitting outside and I'm moving like this, so I mean this position, so this is the position if I'm moving clock, when I will be sending maximum frequency for him. He will receive after some time although, right? And the next time I will be sending the same for him will be from the same position. So max to max gap. One thing we need to observe, if this is one of the detectors who is outside, it's clear that he will have a time period of 24 seconds because that gap is also 24. Although remember, if he sends something here, now what I'm saying now will be used in the last step. So you have to be careful. What I send for him here at 0, he will receive after some delta t. He will receive at delta t. And I'll send the same for him at capital T. So he will receive at capital T plus delta t. So that gap is again capital T. And that's why I'm saying if that capital T is 24, so this is also 24. Now somebody can say that how come you know that that detector is outside? It is possible that both of them are inside. That means looking into the data, we have to judge this thing also. I'll come to this question again, don't worry, because I have to find out the exact distance between the two sources. So anything which you are not able to understand now, by the end of this problem, everything will be justified. So don't worry. I'll justify everything, why I'm taking this. But presume this thing, for this moment, just assume that one of the detector is outside and one of them is, now, why that is inside, I'll prove it. But tell me, if I justify somehow by geometry that the other detector is inside, if I prove this, if I prove it, then for the same motion, can you justify that this time period 24 seconds is justified? If he is inside? Outside के लिए तो it is very clear for max and min. Inside also, we can try to write the expression. So let's do one thing. Let us first try to justify that one of them is outside, one of them is inside. Let's see first what exactly is happening so that you can tell me that the time period here comes out to be 24 seconds. Can both of them be outside? Tell me. Few things which we can contradict. If both of them were outside, then they should have the same graph. Same circular path I am moving, whatever be the location outside, it doesn't matter. The distance doesn't matter there because angle is what I have to take. So both of them cannot be outside for sure. Okay, ये बात तो clear है. Second thing, can any one of them be on the periphery of the circle out of these two? No. Because that will be sudden change. That function is going to blow there, which is not happening. We have got valid values everywhere. So at that place, it will tend to infinity term. That term will come. So suddenly 0 or infinity That is not happening. So one thing is for sure कि कोई बाहर है कोई अंदर है, ऐसा है. या हो सकता है someone can say, sir, it is possible that both of them are inside. But for sure, both of them are not outside. Even if both of them were inside, still the same problem. So both of them can't be inside also. Right? Now, let's see what more can we touch out of it. Up to this point, whatever I have said is fine. You know? So now let us gradually build the problem. For outside person or for inside person, let us try to write the possible frequencies. And one thing we need to understand, the max and the min by one of them is 1300 and 800, right? The values which are given here is 1300 hertz and 800 hertz. Max and min for one of them. दूसरे का max और min different है. This information in itself is sufficient to judge. How come? Let me try to write the expression of F max and F min for person who's outside and person who's inside. So just keep this page as such. I'll come back to it. Let me try to derive a result first. लिखते हैं. पहले बाहर कोई बंदा लेते हैं. And let's say his distance from the center is D0. Let me derive the expression, and somebody is moving on a circular path clockwise. पहले ये derive कर लेते हैं. What is the expression of frequency that he will receive? लिख रहा. Any general point. This is my tangent. This guy is somewhere here. If this angle is some phi naught, and I'm moving with a velocity v, v हो गया, phi naught हो गया, d naught हो गया, r हो गया. Let me write the apparent frequency that he will receive, and the f apparent for this person who is outside, right? The detector who is outside will be equal to. So that is the actual frequency f, a factor of c, and upon c minus v cos of phi naught. That is what I'll get. Course उसकी तरफ move कर रहा है with v cos phi naught. All good up to this point? तो आपको मिल रहा है this term is f upon 1 minus v upon c cos phi naught term. Just try to write this expression carefully for different positions of this person. क्या क्या आ रहा है? F max is coming out as phi naught will be 0, and in other case it will be -1. So +1 -1. So what I'm getting is for the two tangential positions, I'm getting f upon 1 minus v by c and f upon 1 plus v by c. Now, the reason I have written it in this form is I want to compare the same terms for a person who's sitting inside. And through graph, then I will contradict कि कौन अंदर है, कौन बाहर है. So general geometrical terms I want to write. Write for f apparent inside. लिखो जरा, देखें. Remember this v that I have used everywhere, that term is r omega. More important thing that I need here. और इसका जो f out का max है और min है, ये याद रखना. This is f out max term apparent, and this is f out min term. Now I want to calculate f in max and f in min. Derive a general expression. देखते. For a general position inside, what I am doing is I'm taking this guy inside, detector inside. I am sitting somewhere here. These lines are connected. This guy is moving with velocity v. which is r omega. His distance is di. This distance is di. This is r. And maybe this angle is some alpha beta, whatever you want to take. So let's try to use sine rule and eliminate all this. So if this angle is alpha, this f inside person, the apparent that he will receive is the f actual f c minus v cos alpha tau. Now this angle is 90, so this will be 90 minus alpha. So sine of this term, call this beta. So I am getting sine beta term. Right? ठीक बात है? And for different positions on the ring, try to use sine rule in that triangle once. एक बार use करना. Because if we use this angle as our gamma, right? We can write sine gamma upon r term is equal to that sine beta upon di term. So I want to incorporate this as f upon 1 minus v upon c times sine beta. And that becomes di upon r times sine gamma term. Observe it. F upon 1 minus v by c is there, di upon r term is there, and sine gamma term is there. Now these are the constants, so no hassles with this. Now I was interested in f inca max, and I was interested in, and from this you can also find out the positions, and f in min. So that max is coming out as a minus term. Sine gamma term being equal to 1. Right? So, I mean, when it is perpendicular to this radial line, that is that position. Is that clear? So, it becomes f upon 1 minus v by c times di upon r, because di was not known, no? That's why we were not able to directly tell where it is. But depending upon di, now I am in a position. And min comes out as f upon 1 plus v di by c into r. Check this carefully, both max and min. And not only this, this f in max seems to be less than f out max. उससे तो छोटा लग रहा है क्योंकि that value was 1 minus v by c, ना? And f in min is in this case, compare with that. वो ग्राफ कैसा दिया था उसने, इससे थोड़ा आइडिया लग जाएगा. Yeah, is this less than f out min? Greater than is greater than f out min. Now at least that graph is making sense to you. क्योंकि जो बीच वाला ग्राफ था उसका जो मैक्स था वो छोटा था दूसरे वाले से, एंड दैट मिन जो था दैट वाज ग्रेटर देन दैट अदर वन. तो आउट इन का टर्म तो दिख रहा है. Up to this point things are settling out. And not only this, the positions are also very clear to you now. So while you are moving on this circular path, you can mark those two positions where you find that corresponding to which you will find your maximum and minimum frequencies. On this circle, it is clear, na? There, that sine gamma term is coming out as 1. And secondly, that angle was coming out as pi, minus pi by 2. 3 pi by 2. ठीक है ना? So in this diagram, you understand those two positions. I think this line. So corresponding to this point and this point, these are the 2 points corresponding to which you are receiving your min and max. So this we have to take care of while So whenever you will give me that position, the inner detector position, so I will divide, I mean, that is on a radial line. So the two positions where I'm getting max and min will be divided symmetrically about this line such that this angle is 90. Is that fine? Right? So this much data is there. Now you can go back to the previous case and you can sort out a lot of things. So, as far as the time is concerned, now you are clear that max is going to again come after 1. And so if this is the position of max and this corresponds to position of min, then between max to min, there is a gap which is constant again and again, and max to max again a time period. So max to max in both the case is the time period. So when he says what is the time period, I'm convinced that the time period is 24 seconds. This much is fine. Max to min, if you observe, you are getting 9 seconds here and 9 seconds also here. That basically means that the angle that this guy will traverse here, this angle, right? Let me call this as some theta naught, what he will traverse here. And in the second situation, when the same guy will travel like this, the angle that he will traverse here, these angles will be the same because he has got a constant omega. I will draw a common plot for both the people, don't worry. But I'm just trying to put down data from discrete places appropriately. If with respect to the inner person, I will find out the angle subtended. And with respect to the outer also angle subtended. Because that gap is the same, that means that angle is also same. This much is fine. Okay, now let us, before I start solving the question, it's better to read the problem carefully. So first part of the problem said, determine the time period, we got it. Second part says, figure below shows the circular trajectory, qualitatively mark the positions of both the detector and hence. So that's fine. Qualitatively, we have analyzed this problem. Let's move on to the more quantitative parts in the question. So now let me take you to the second part of the problem. ये बना दिया था क्या? Read the C and the D parts of the question. Now I'm interested in, and I will take you to the graph again, don't worry. I'm interested in calculation of the frequency of the source, which seems simple. And this was the question I was talking about, where I have the main interest, the distance between the detectors. So before I come to that part, let us first try to find out the frequency of the source. Go to C part, try to find out the frequency. So if this thing is clear that one graph is for the outer person and one is for the inner one, so for the outer person, F actual upon 1 minus V by C, that is 1300 from the graph. You know that. And F upon 1 plus V upon C, that value from the graph was 800. This is given to you. Solve these two equations, get the value of F or F naught. F naught, F is same. And also find out V from this, solve it. Because in the problem, already we have calculated the time period. Capital T term nikal liya. Right? Capital T is known to us and C is also known. The known, he has given you C in the problem, that was 330 meter per second. I've calculated capital T, which is 2 pi by omega term, which is actually 24 seconds. यहाँ तक ठीक है? तो क्या निकल के आ रहा है? I think V by C can be eliminated. F तो आ रहा होगा. What is the value of F? If you calculate it properly, it comes out as 991 hertz, around 991 hertz. From these two equations, eliminate V by C. And from this, You even calculate your V, and that will help you out, because V यहाँ से जो calculate होता है वो 78.6 आ जाता है. Solving these equations, you'll get your V also, and this V will help you calculating the radius of the circle. So that comes out as 78.6 divided by omega term, and that omega is 2 pi by time period. So 2 into 3.14 upon 24. So, I mean, your radius is also around 300 meters. You calculate it correctly, this comes as around 300 meters. Leave it. Now can we find out the distance between the detectors? Again, draw the geometry of the question, and with all this information available, we can try to find out the result. I'll again take you to the graph of the question so that you stay aligned with the problem. अब वो डायग्राम अगर ज्योमेट्री से बन जाए, then I can find out the result. So let me finally try to draw that diagram. अब ध्यान से देखना. So I want to position my outside detector somewhere here, D outside. I know that the two tangential positions which we are interested in are somehow like this. अब जो इनसाइड डिटेक्टर है उसके बारे में, वो जो थीटा थीटा वाला पॉइंट था, हाउ विल यू यूटिलाइज दैट पॉइंट इन द प्रॉब्लम? I'm drawing few things, just check the data correctly. So I'm marking these points properly. I'm getting this point as A naught, and I'm marking this as A naught prime. This is our D out. And as far as my D in is concerned, I'm looking into D in with respect to 2 points and the bisector of that, and somewhere here I'm plotting my D inside. This guy is D inside, right? I categorically said that this angle here I depicted as theta naught. यही कहा था, from this position to this position, and I was clear that in that span, the angle that he will subtend here and the second point, I mean that A naught prime wala point, that total angle is also theta. So if you want to draw this symmetrically, this point is there and that angle subtended is also theta naught. Ultimately, what we are trying to do, we will try to use cosine rule and solve this problem. The distance between these two people. So can you geometrically give me, R is known to you now. R is known. And can you just tell me this angle also? The angle that I'm calling upon as theta naught, I can write that because I already know the value of omega. So जिसको मैं theta naught बोल रहा हूं, that I can calculate by omega. And I know the time also. So what is the omega that I have calculated? And time from max to min was 9. That is basically the value 9 omega. If you check this, this comes out to be around 3 pi by 4. ये value तो 3 pi by 4 आ गई. 9 omega is coming out as 3 pi by 4. This much is fine. Now, with respect to R, just try to write the values. I mean, R के terms में लिखने का कोशिश करो आप value. Distance of D naught from the center and DI from the center. दोनों आ जाएंगे. Write the distances DI and D naught. DI क्या लिखने में आ रहा है? और डी नॉट क्या आ रहा है. If you know this angle, then I think d naught distance is known to us in terms of r. Like this distance d naught is known to us because I know the total angle. ठीक है, तो निकाल लो. And di also I know because again, I mean, seems like कि अगर ये theta naught है and this angle is theta naught by 2, this angle here is 90. So d naught cos theta naught by 2 is r. Seems like r upon cos theta naught by 2. You can check this, cos theta naught by 2. And similarly, this also seems to be di. Di also seems to be what? R, this is r cos theta naught by 2. Cos theta naught. R का cos theta naught by 2 look. और r d naught का cos theta by 2 look. All good. And theta naught is also known. And r I have already calculated. R previously I have already calculated. So r is also known. यहाँ तक पहुंच गए. Now the only thing required is the angle. So if we can somehow finally just complete this triangle properly, this one. I mean, this distance is what is required. This distance. This is your answer. तो अगर वो एंगल में लिख दूं बीच में तो रिजल्ट आ जाएगा. So the only interest at this stage for me is to find out this angle alpha, and cosine of alpha is going to work for me. What is that? Di square plus d naught square minus the required answer square upon twice of di d naught. This equation should help me find out my result. Di known, d naught known, r, theta naught, omega, all the parameters known. Only interest is to write the value of alpha. If I can write that, I think it will work out. Just all good up to this stage. The most important step is the last one. And there we have to take a time delay term. So I'm writing one expression and you tell me why this is correct. The expression of alpha I have to find out. I'm writing one equation, tell me why is it correct. So 4 seconds is alpha upon omega plus the distance of AI with d in, AI d in upon c minus a naught d out divided by c. Why? If this is justified, and angle here is in radians, alpha in radians, then we can find out the result. And the terms मैंने क्या लिया, a naught prime लिया और ai prime. So this blue point is ai here, and इसका जो counter है, this guy here, this is ai prime. And this is not the intersection point of the green line, so that's a coincidence. Let me explain what I'm trying to do here. The point is, this expression is because of the time delay, right? Whatever started from this point will be received as an apparent frequency after a time delay of a naught d naught by c. D out, this guy is d out. So this term is because of the time that he will take from here. And the second term is because of the time that the blue guy will take from this point to this point. Yani yellow mein the maximum frequency. So if at 0 a frequency या cluster of waves starts for him, which he knew will have maximum apparent, then that won't be received at 0. And graph is plotted with respect to a common watch. So that will be received by him at this time instance. So if I And when I pass, the same guy pass from AI, he throws a max for his friend here, the inner friend, and he also doesn't receives it immediately. He receives it after this time. If these two terms were not there, then it was simple alpha upon omega. And in the beginning only, I said that time is known to me. That means what I'm trying to say, this 4 seconds is what I'm taking, this 4. The max of the outer guy and the max of the inner guy, that received, the time gap detected was 4 seconds. But 4 seconds cannot be written as alpha upon omega. Remember, you understand this alpha here and the same alpha bit for max here and the max here. You are clear about this, huh? Because theta remains the same. So with respect to A0 and AI, I'm talking about this angle. This angle is also alpha. This is fine. Same triangle, same angles. This angle was alpha. So tell me, if I read the data in the chart, the time was 4 seconds. So I would have thought कि इसका max और इसके max के बीच का gap कितना है? 4. तो 4 को मैं लिख देता angle upon omega. This term is generally what the students miss. Everything is fine. That's why I say this is not a 4. 4 is actually the gap between the receival and the receival here. So the thing that you throw at 0 reaches here at 0 plus this time, which is A0 D out by C. This is one time instance. He receives the max. Look at the inner guy. For the inner person, the maximum is thrown from this point, and that time is already alpha upon omega. And then he takes additional time to reach here, and that time is AI D in divided by C. So the time of receival of max frequency of inner guy is this, and time of receival of max frequency for outer guy is this, and their time difference is. That's why I said this minus this should be equal to. Now everything falls in place. It is more about calculation from this problem. All the individual informations are known. I think you can find out A0 D out again in the same lines because R is given and that angle was theta naught by 2. So in terms of tan, you can find out those values. I think these distances are fine from the geometry. This term is fine. So this will help you calculate alpha. Alpha is substitute here, get your answer. Those individual yellow and blue triangles are known to us, and I have already depicted the value of alpha in that diagram properly. So you should go through the calculations now. I'm not doing the extensive calculation, but you know that point was important in JEE, not related to calculation, but this point he can always use. Circular motion dekha, ye sab hua. Generally, that last step is also something which we miss because observer is not going to miss it. He is observing it. He is not saying that I am observing with respect to that instance because there will be some delay. The last step you have to consider that. Got the point, no? So I'll finish off the class here only, and you go through the calculations and analyze the problem even better way, right?